Hello, everyone. So, yeah, we tried to sit. We should roughly be sitting the right way now, aligned with our picture up there. So, this is going to be a panel, but we do want to learn a little bit more about some of the frontiers in XR and that my colleagues and I here are working on. We are in different schools. You can see we are all faculty at the University of Michigan, or soon to be faculty, postdoc. And so we learn about each of us a little bit, and then I want to have a conversation with all of you. And you just had lunch, and that was hopefully cool. But let's do an activity. So I want you to imagine how a future of this space here could look like, so that it would be more inclusive, so that it would feel like a space that really creates a place of belonging, something welcoming to you. So think about this, close your eyes. What would you change? Would you remove Michael's voice? Would you change the pitch of my voice? Would you give me an American accent? What would make it feel more inclusive? I want you to think about the environment. So we gave this task in a recent workshop at an academic conference, and we had Gen AI imagine it, and this is what came out. Not this particular space, but actually a conference where we were. So the prompt was futuristic version of an augmented reality user who sees the world as an inclusive space that creates a sense of belonging. My vision for this future of AR, that is something that I'm working on, is that it will be primarily assistive technology. Whether you feel like you need assistance or not, it will be providing a tool to you. What this thing didn't get right is really adapting the environment. It definitely has some Egyptian touch to it and some other aspects to it, but it shows primarily a metaverse and kind of like zombies that are just following Mark Zuckerberg's vision potentially or something like that. So you can interpret this in many different ways. This is not what I had in mind. It's very difficult with Gen AI to imagine the future of, for example, AR. So our panel is on new frontiers in XR. I also would like to participate, so I'll quickly tell you what I'm interested in. So I'm interested in thinking about how we can get rid of the big headset you see in the background and to turn it into something like smart glasses. So we have almost the same glasses here. These are now smart glasses. You probably don't notice any difference. These are now connected online, have cameras. And so what does it take to actually create these glasses of the future? And I'll actually have to put my other glasses on because these have prescription. And I didn't buy that for the toy ones. And so basically, I'm curious, like, how much of a display do we actually need? Everybody's excited about creating advanced displays. I was on sabbatical at Meta, and the task they gave me, Michael, think about a future of AR where we don't actually have a visual display. We cannot create this. And if you saw just recently, they announced Meta Orion just a few weeks ago. So I guess they gave me the wrong task because I was thinking really about how we can get away without a display. And so we clearly have lots of sensors. I just drew them in there. You may not even see them, and that's the point. There's actually so much technology in these glasses. So I'm very excited about it, but also very concerned about it. And I use these technologies to create inclusive spaces. This is an example that you may have heard about. It's called iGym, it's inclusive gym. It allows children in wheelchairs to play against other children who may or may not be disabled. And we kind of like balance the playing field by providing new input, by adjusting the game mechanics. They play air soccer here. So I'm really thinking about like how can we have more inclusive activities and play together. So these are some of the things I'm thinking about. I'm going to pass on to Janet so we can get to know Janet a little bit.
Hi, I'm Janet Johnson. I'm a postdoc at the School of Information. And so the work, what am I supposed to? Yeah, thank you. So the work I've been doing is to understand how we can bring AI into groups. And so all of us collaborate with other people. Most of our creative tasks and problem-solving tasks that we do happens with groups of people, and that's how we've been able to sort of make progress and innovate as we've gone forward with since the beginning of time. And so with this new generative AI technology, I'm looking at how we can use XR to have these generative AI technologies be part of a group and not just sort of augment our individual tasks or help us do individual tasks better the way you might use like ChatGPT today, but how we can bring that into a group setting so it enhances sort of like the intelligence of the group as a whole. And so the generative AI obviously can help expand our creative and problem-solving abilities. It can kind of take on new perspectives. It can help you ideate better. It can tell you like pros and cons of things. And then extended reality is a way to sort of bring that to life where we're not kind of like prompting these interfaces anymore. And it creates this immersive space where you can interact with intelligent like entities, whether it's generative AI or otherwise, in ways that feel more natural and intuitive to us. And we've evolved to sort of work in spaces where naturally a lot of things happen sort of like without us thinking. And so my research looks at how can we use these two technologies to combine that and facilitate or augment how we creatively solve problems in groups today. And there's a special focus on how we leverage sort of these spatial aspects that extended reality brings in, and we probably talk more about it during the panel, but how we can leverage these to be beneficial to groups. And beneficial is not just like, can we do it? It's also how we making sure that it's actually bringing value to groups. Sorry. Yeah, so I just want to touch upon maybe...
To build on Betty's point, integrating IoT for smart lighting in a city like Singapore involves using sensors and real-time data to adjust lighting based on traffic flow and pedestrian movement. To build on...
Sorry.
I had one task.
My bad, that was my bad. But yeah, so one of the projects we're doing right now is we're looking at how we bring these entities to life and say, have a group discussion where these AIs can participate more as active contributors as opposed to something that you would just use on a laptop by yourself. And so we built this prototype where we have agents represented as sort of humanoid avatars, and they're like people around and they can have this conversation. These agents can like listen to that conversation and kind of get the gist of it and contribute to that conversation by bringing in different perspectives. So you can have different forms of expertise that's embodied within a certain agent, and they can bring that perspective to a discussion. They can also, right now, they can raise their hand and be like, I have something to contribute. And so we are also looking at like, how do we take the social cues and the social use of space into mind? So the video is just sort of an example of what that might look like. Yeah.
To build on Betty's point, integrating IoT for smart lighting in a city like Singapore involves using sensors and real-time data to adjust lighting based on traffic flow and pedestrian movement. This not only improves energy efficiency but also enhances public safety by ensuring well-lit streets and reducing accidents.
To further enhance the effectiveness of smart lighting systems, we could consider integrating AI algorithms that predict peak usage times and adjust lighting accordingly. Additionally, involving community feedback mechanisms can ensure that these systems meet the actual needs of residents, thus optimizing both energy.
So that's just an example of what that looks like, and then a lot of our work is sort of embedding that into real human conversations and teams and understanding it. But yeah, exciting, but there's a lot of open questions there. And
Right, thanks, Janet. Let's meet Giusy.
Hello, hi. Oh, this is really high. So first of all, I'm Giusy Falcone and I'm from the aerospace department. I'm a faculty there. So if we can go to the next slide. I did put some animation, but it's never gonna get the Bluetooth on here. Yeah, you can go ahead. So my work is actually in guidance, navigation, and control for spacecraft, and my research group is called the Space Falcon Lab. You will ask how she is doing guidance, navigation, and control and XR. So the idea here is I am actually working on also artificial intelligence for guidance, navigation, and control and autonomous decision making for spacecraft. And the idea here is to actually provide information and create an environment that otherwise would not be able to have at the moment. So if you can go to the next one. So obviously, when you talk about space, we actually miss a lot of data. We don't have enough data. There are spaces that are way richer of data. For example, like we are talking about Earth application, but more farther you go and harder it is. However, also like on Earth, we do have data, but we don't have enough data to, for example, detect fire or detect a tornado. What we currently do is from Earth, we detect them and then tell to the spacecraft how to do it. Another thing is obviously like more complex data there are. If you think about when you are doing a mission design perspective, so you have a spacecraft in orbit and is really changing both from a time frame perspective. So you have things that happen like, I don't know, every 4 hours around Earth. So, you know, the spacecraft is going to take 3-4 hours to rotate around. However, also there is things that happen on the time scale of 10 seconds. For example, if you are pointing your telescope or things like this. At the same time, so there is different time scale and also different sizing, normalizing sizing. Like you are talking about an orbit, but then you are talking about close proximity operations, so two spacecraft that go really close to each other. So it's extremely hard if you are not into the space already to understand how to pass from one thing to another one. So there is like also a really rich background on studying like from an educational perspective, how we are teaching to our students what to do and how kind of like learning from this. So the idea that we currently have is indeed like trying to use Gen AI both to recreate data, to recreate, for example, image of Earth and see like how these, if these can be used then to train for a future spacecraft that scouts these kind of ideas. At the same time, try to use to give like really fast scenarios, recreation. Think about Mars Curiosity or Perseverance on Mars. How they are being guided at the moment is taking the camera feed sent to JPL, and then JPL has an exact replica of Curiosity and Perseverance and put stones where they are supposed to be and then replicate the guidance for 10 meters. Send back the data and do this over and over. So what if we can recreate fast scenarios just using virtual reality or extended reality in general, so having also an augmentation on that side. We can go to the next slide. So what we are currently working on indeed is both extended reality XR for the simulation space mission planning and recreation of hybrid simulation. So where we have some real components, for example, a rover or a robotic arm, but there is then a layer of virtual, and so how the two things can collaborate to each other. And then indeed recreate this image definition or a training AI model for autonomous decision making. On the left side, indeed, this is actually a map, a picture that my student recreated with Blender using different maps from NASA. And the idea here is like, how can we then randomize the clouds and use them? And can we kind of fake it and see if we can make it pass as real image? On the right side, instead, we have my idea of what my lab will be. This actually I created with generative AI, just to say, but it's really far from what is at the moment. And of course, this also gives you something like that we really miss in space, which is spatial awareness. How to provide information to operators that most of the time they are really good, like really good professionals, but information that are currently lacking. And then we can speak more about this. Thank you.
Thank you, Giusy. And now we'll hear a little bit from Jiasi Chen on what you're interested in and what frontiers in XR you see.
Hello, I'm Jiasi Chen. So I'm in the Electrical Engineering and Computer Science department. Let me tell you about some products that I work on related to AR and AI. So you see bullet A there is generating a 3D model. I input a text prompt of a corgi, and out comes a 3D corgi. So why do I want to create a corgi? This is a project with Meta. And one of our examples is that you're viewing an apartment or a house in 3D, and you want to personalize the environment and imagine I have a little pet corgi, let's say, and I want to view my corgi and imagine this apartment is my own. So I can tell my AR headset, hey, make me a corgi, and it's going to make me a 3D corgi and put it there, and it can run around and chew on my furniture. So this is one example of 3D models. And another example is then you want to edit these 3D models. That's point B there. So maybe this one is a truck, but the truck, I need to move the truck to view what's behind it. And where AI helps here is we can make AI fill in some missing background for the truck because we don't know what was actually there. So these are kind of examples of things we could do with generative AI. And a really key aspect of my research is making these things actually work on headsets. So just before this panel started, Michael was trying to show off his XR glasses to Giusy. And we asked the XR glasses to do something for us, analyze what was in the image. And what the glasses say, the Ray-Ban glasses, it said, network connectivity unavailable. So my point is, most of the time, these kind of services need connectivity to the cloud, right, to these powerful ChatGPT or large language models that are running on big servers somewhere. But my goal is to make these kind of services work well, even on just a headset, which is kind of like your phone, right? It doesn't have a lot of battery, doesn't have a lot of compute. So how can we make these things run efficiently on resource-constrained headsets? Yeah, next. And another product I work on is about AR security. So I won't go into the details there, but let me just say that AR and XR is new technology. So there are a lot of security flaws that myself and others are working on. So here we're exploring how to use AI to help defend against security issues. So this example here is we ask AI to help us detect image spoofing. If I show my AR headset a photograph versus the real world environment, we can ask AI to help us, hey, is this the real world or is this just a photograph? And this ends up being useful for some of the security attacks we've explored. So overall, you can see my thesis is that, or my challenge that I face is how to make these powerful AI models work well on these headsets with low power and low latency and have a good user experience. Thank you.
This is just the first part of the panel. Let me go to, I don't have like a really good slide to end this. I'm just trying to get to, I'll show the one where you see our names. I'd like this to be an interactive panel. Many of us are working on different topics, but I'm just going to the first slide and I'm doing this in the most clumsy way possible. So just so to check your memory. So you've learned about the work that my colleagues and I are doing here at Michigan. I wanted some of these frontiers that I wanted to talk about include inclusion and accessibility that I wanted to talk about today, collaboration and actually interacting with AI in human ways and integrating AI potentially in the environment and all the things in groups and group work that Janet was talking about. You can see that when you open OpenAI right now, it's an individual interaction. There's no sense of teamwork. And so this is a frontier, I think, that you're taking on. Space, I wanted space, the final frontier, to be part of our frontiers in XR. And Giusy is making good progress there. And Jiasi, who gave us the example of the corgi that I love, and also is an expert in edge computing and actually in security and privacy. So I think these are some of the challenges. I'm sure another obvious one, or some of the frontiers, I'm sure another obvious one relevant to you all in the audience is education. So I didn't specifically highlight that, but it is a theme in a lot of our work. We obviously interact a lot with users, humans from the general public. Janet was actually doing a bunch of workshops in the Detroit area recently to introduce this idea of generative AI agents. And so that is why we have this panel. So if there are questions right now that you feel like, that would be a good thing to ask, we can do that. Otherwise, I have a bunch of themes for us to discuss. But if there's anything that you wanted to follow up on right now, yeah. All right, cool. Jeremy, can you help us?
Yep.
Thank you.
You're inaudible there. I wasn't
And
ready.
when you ask a question, can you say whether you want it to be answered by somebody specific on the panel or just a question to them?
Well, this addressed both what you mentioned and what Dr. Chen mentioned. I was wondering what has been the holdup with regard to wearables and making headsets more streamlined, shall we say? I'm sure many people remember Google Glass, and that has been sort of roundly panned. And compare that to the iPhone. iPhone has gone through like 16 generations now. I'm wondering why hasn't the Google Glass gone through 16 generations to the point where it could be a lot more functional in the ways that were described by Dr. Chen. And also things like, instead of having a center console on your in your vehicle cabin, why not have something implanted into the windshield itself? AR, VR. So has the limitation been technological or psychological, or what would you say for that?
So I think a lot about this. Also shout out to my students who came from my classes here. Thanks for coming. We think a lot about examples like Google Glass, and while in many people's eyes and ears, it's associated with failure. But I think it didn't necessarily fail. It was just too early. I think the primary challenge are on the societal side. So I remember I was at ETH Zurich. I was a PhD student there, and they had a wearable computing workshop just around the time 2012 when Google Glass came out, and people were going through the pedestrian precinct with all these glasses on. And first of all, not everybody realized that these glasses are different from other glasses. So that is a challenge and an issue in itself. But I could observe people just think something odd is going on. Are these from outer space? Are these aliens who just... So there's a group of 20 people walking around with smart glasses in 2012, which is unheard of at the time. So I think there's also technological challenges. So the way Google Glass specifically worked out is like basically many of you actually wear glasses right now. And one of the things is whether glasses will actually find adoption into society in the future. It's easy for us who rely on them already. It seems like, cool, this could be potentially an added benefit. But in movies and in pop culture, people wearing glasses are usually the nerds. There's some kind of like negative image associated with them. And we were just debating this internally at Meta in a kind of like a fun chat group, what we would need to do to change this perception. I wear my glasses happily now, but I remember when I had to get them, I was disappointed. Am I getting old? What's wrong with me? And this may not resonate with you, or it may resonate with some of you. And then the future is maybe that we all want to buy these glasses because I don't want to take my phone out of my pocket anymore. So the pitch is not, so the value add, the value proposition isn't really there yet. It could be. I'm wondering, so these are the things that I think about. Jiasi, what would you say?
Yeah, I think you captured a lot of the points really well. I agree with you. It's sort of a chicken and egg problem, right? We need these really cool killer applications that people are going to want to use, just like you pull your phone out of your pocket and check your email all the time. So we need both the killer apps, and we also need the technology to support it so that it's sort of easy to wear, comfortable, people accept it, and it has a good user experience. So it's totally a chicken and egg problem. On the second question you asked about, like, why not other types of non-wearables, I think those are definitely, people are exploring them. So we have collaborators at some of the automakers, and they're all interested in these the AR, like heads-up display on your car. There's a lot of research going on there, but again, the question I hear from them is like, what is the killer app, right? We have navigation already. What other things do we need? We can do traffic reconstruction. We can do pedestrian warnings, but is there a commercial case for it? So I think that solves the question in the end.
Thank you.
To be honest, the AR display was the first thing I disabled in my car. As an AR enthusiast, my wife got a new car and had this AR display, and just from a focal length, it just seemed to I have to really focus on the windshield, and I'm afraid that I'll actually hit the car behind the windshield because my focus really has to adjust. So it's there are challenges going forward as well, but we will probably see more of these technologies in cars.
Hi, my name is Ali Satari. Thank you for sharing those use cases. My question is for Dr. Chen. Could you share a little bit about the process and the platforms you use?
Sure. Could you the process of developing these ideas, or the
No, for like implementation, for example, like how did you create that corgi, or like for filling the background of that like in that 3D model?
Yeah, so the examples with the corgi, generating the 3D corgi, or filling in the missing background of the 3D scene. A lot of people work on these in the computer vision field, making these very powerful new computer vision models or large language models that can do these things. So our research is focused on trying to see how well those perform on a real headset. So making a corgi or making a 3D scene can take hours, even on like a very powerful data center. And when you try to run it on a mobile device, it's like 10 times worse, right? So no one is going to wait no matter how much they love corgis, no one is going to wait 10 hours for their corgi, right? So we try to take these computer vision models and try them out on more resource-constrained devices to try to understand what are their bottlenecks in performance. Is it memory? Is it GPU? Is it CPU? So what are the problems? And then try to find ways to address them.
Right, thank you for your question. I think we have another one.
More question here.
So hello, my name is Jingo. Thank you all for sharing your work. So my question is more geared toward Dr. Johnson. So in your work, you explored having virtual humanoid agent in augmented reality environment. So I actually have two questions. First is comparing to other form of robots, like what's the benefit of using humanoid robots in that environment? And the second question is comparing to like having a physical robots like Jibo, for example, that's enhanced by XR technologies. What's the benefit of having a fully virtual agent in that environment?
Those are great questions. So I'll answer the first one, which is sort of why a humanoid sort of form. I actually don't have an answer to that. The humanoid form was something we used in sort of our experiments, but it could take any form. And one of the things we're learning, so we did these speculative design workshops with real teams where they use these prototypes. And one of the things we're learning is that both how you represent an agent sort of affects how a user will perceive its role. So if you have sort of like a cube floating around, they're like, oh, it's more of a tool, versus if you have a humanoid avatar, maybe you see it more as a collaborator. And there are both pros and cons for that. Like, you kind of want people to be appropriately reliant on the AI. So you want them to be able to get the benefits of the AI while sort of minimizing these harms. So you want them to have a realistic sense of what they can expect from that. And these like snap judgments we make when we look at something can sort of help with that. So if you want this AI to be sort of deliberative and be part of a discussion and bring in more subjective forms, maybe you want to give it more of a human sort of form. Maybe you want people to just look at it as facts, and maybe that's when you use something like a cube. So the answer is we don't know, and I think there's a lot more work to be done there. There's also the aspect of how you perceive it is based on your lived experience, and so it might change for each person. And that, I think, leads to the second question, which is like why in XR and why not like a physical robot? I think the more obvious answer for me is that it allows things to be portable. So, you can be anywhere, you can be working from home, you can be in a different space, and you don't have this physical constraint. But there's sort of this piece with XR that you don't get with other technologies, which probably is where a lot of the value and the risks come in, which is that each person has a headset that they're seeing the world through. And so you can modify that world to work for that individual. So you can use that in good ways where you can have, say, what an agent looks like be catered to an individual to make sure that they're appropriately reliant on it. But there's obviously risks there with the fact that breaks sort of our shared reality. And but that's sort of the main, I don't know if it's an advantage, but the main difference, I think, with physical versus XR.
Gonna expand two things. So I like how you didn't do it here, Janet, but normally you call this a prototype, not a prototype, but a prototype. It's designed to provoke. And also those of you who care about design, one of the issues was, so one of the things I think we made a good decision is these robots, AIs, actually wear headsets. There's no need for them to wear headsets. They are virtual avatars. So we put headsets on their heads to kind of like balance and make it even and equalized, and some, but also remove some uncanny valley effects, because when the eyes don't move properly, it creates some very awkward experiences. So these are some of the things I really like when I look at your prototype. So let's go to space.
If I can add on, so from another perspective, where space instead is pretty hardware size, right? So sometimes we actually cannot send hardware. Hardware is expensive, and also hardware requires a lot of failure. So I do see that as could be seen as a first step, or when you actually don't have any type of, you cannot spend that cost for more, both from a risk perspective, but then also from a cost perspective. And also as well, like it depends also on accessibility, right? So not everyone has robots, not only in space, generally. So I do think that they have, like, my honest opinion on that is that they have different values on where you can use one or you can use the other one. Not one technology is eliminating the second one.
So I'm going to throw one in because we're on the point of robots. So I saw some videos of some of these kind of like, was it SpaceX or like police robots that were going around on Twitter. I'm not sure whether you saw those. So they're kind of like advanced. So should future police officers look more like robots, or should they look more human? What do you think in this specific setting on Earth? What's your perception there?
Hard to say. I mean, I think that I don't have the social background to represent that. I think that it's a lot of knowledge about the perception of people and society. And I feel I don't want to eliminate the question, but I feel that I don't have that type of knowledge on that.
I don't know what the right answer to that one is. I just wanted to provoke. Mission accomplished. We have
Question over here.
Hi there. So I am personally interested in my career goals is regarding the self-sufficient robots in space. So one of the concerns, obviously, with that is if they are self-replicating, if there's any kind of control loss with those, it could definitely cause like actual threats towards humanity, right? So with that regard, how would we better prepare humanity to be able to safely move forward with like the software, being able to control the software? What would be some suggestions that you would use that?
Stop playing with the microphone. But so yes, so there is a lot of interest about, so when you talk about autonomy in robots, it can be functional autonomy or system autonomy. So functional autonomy is where, for example, you have a robotic arm and you're just like, moving the robotic arm. And instead, the system autonomy is when you want to land on Titan and your spacecraft is landing for yourself. Like, it's completely defined what resources has, what capability has, and they can do that. So there is like a little bit of interest on not providing system autonomies to robots for that kind of reason. No one wants to spend like $1 million, $1 billion mission to then fail the mission because you have a failure on the decision that you're taking. And no one wants to take a decision where a risk decision so high provided after you have worked so hard on a project to a robot, right? Like, who would have done that? So on that side, there is a little bit of not wanting to do so. However, we are really still far on, the threatening part. We are really, really far from that. And we need to see how this explodes in time. Maybe like, things can be, obviously threats, I'm thinking like, aloud and brainstorming here, threats can be a different level in the sense that can be from defense perspective, or if you are actually bringing back, any type of microorganism that will not supposed to be for planetary protection or things like this. So obviously these are all really hard questions, and so we still need to have a human in the loop. So indeed, my work is in autonomous decision making, and especially on how humans make decision and how we can give the same decision idea to robots. So, yeah.
All right, I'm going to throw something in. I was just at a conference the other 2 days in Pittsburgh, one of our main human-computer interaction conferences, user interface software and technology. And there was a debate on how to design AI and how to define the agency between the user and the AI. And many of you use the term human in the loop. Sometimes we use it as a limitation because we couldn't do better, so we still rely on a human. And in human-computer interaction, somebody talked about computer in the loop. It's about the human. The computer is in the loop, and the computer could be a tool, it could be an assistant, it could be your slave. It can be whatever you want to make it. But defining this agency will probably be one of the main questions in the next few years, also at the intersection of AR and VR with AI. So this panel is called Frontiers in XR. So far, we've talked about the frontiers that we all try to bridge, what are currently maybe the challenges for us, the limitations. In this space, I'm sure this happens to a lot of you as well. People always come to me and ask me, Michael, could you do this? Could you do that? And for example, could you bring back my brother who died a few years ago? And this happened in an office hour, and I was debating this. So technically, I can probably do it. Should I do it? So I want to explore, maybe just for the remaining minutes, there are frontiers that we set ourselves that we really don't want to cross. Or if anybody crosses them, should we say no, or should we be part of it? For example, I have not received military funding, but Microsoft Research had a very expensive contract with the military to make the HoloLens 2 an assistive device for soldiers. And there was the debate who should get this, and whether Microsoft should get it or some of the other players in the space. And my perception at the time was, so it created a lot of issues. People left Microsoft after this happened, so maybe you are aware of this. But my perception was, in the end, there is a social contract, there's a responsibility for Microsoft, so I was actually quite glad that they got it rather than some of the other players in the field. So sometimes I haven't brought back my brother in AR or in VR. It could be an interesting experience, I think. I showed VR to my mother. She was visiting recently, and she was surprised by the progress we make here. But I don't think I will go there. So this is a frontier I've set for myself. I have the technology. You see everything there. I can make these agents look photorealistic. I decided to make them ugly. I decided to make them what we call medium fidelity, just to not create too many conflicts. Janet, are there things like frontiers that you really want to stay as frontiers in your work?
That I wouldn't want to go to?
Design around these frontiers.
Yeah, I think so. I think when we think about having AI in the mix of like group collaboration or that discussion, if you're sitting around, there are obviously going to be cases where the AI is going to know the answer. But I think there's value in sort of that human process of like going through that discussion with others, even if it's discussing what the AI is telling us. And so I think like for me, the line is going to be making sure that humans have control and agency around that process. And and not just having sort of like AIs fix things for us. Like that's not what we want. We want to be able to critically engage with it and think through the input it's giving us. I maybe have a more optimistic take on it. Like I think it's scary to have sort of like these AIs coming into our lives and into our workforces and teams in basically full force, and we're sort of left grappling with it. But I think a lot of times we can organize ourselves as like human beings to make sure that control stays with the humans. And so one of the things I have been exploring and want to continue exploring is XR actually gives us that sort of opportunity because you can use the space. So if you have an AI agent sitting at a round table with you, because we tend to give people at tables, if it's a round table, we tend to give every entity an equal voice. That's how round tables work. But then if you have the AI agent, let's say, farther away or spatially represented in different ways, then we can sort of like make sure that that control stays with the humans and we're still engaging with it. So I think the sort of soft line is making sure that the AI is there to foster the collaboration amongst the human beings as opposed to doing the task itself.
Do any of you have an example?
Sure. So from my perspective, instead, my ultimate goal, for example, in this specific area of XR, it's how to, again, like how to gain information of how human, especially like people that are really skilled, are making decisions, to then provide this knowledge to the robots. However, like I do realize that making decision, you know, if you give a perspective that is biased, the decision will be biased. And so that is where you can kind of like then cross the line, I think. And what I think that is really important is to provide information that are, you know, unbiased, uncorrect, and from different perspective, like especially like how indeed a human will make a decision itself. So that is where I don't want to cross the line, yeah.
Right. Jeremy, do you want to look for another question, or should we?
One more question, if folks have a question.
All right. In the last few minutes of our panel, thank you so far.
Thank you for sharing. These are very inspiring. And I have a question for Michael. So when it comes to assistive technology, how to make XR exploration more accessible, and how to make sure that everyone have access to this technology, especially, for instance, people cannot see or with low vision. And we're talking a lot about headset or advanced glasses, but what if they cannot even see it? How can we make sure they can also enjoy the immersive experience?
Thank you for the question. It's like this was not scripted, but I love the question. First of all, it allows me to unpack accessibility as a technical term. So there's access and equity, like having access to these devices. And I think these devices are becoming cheaper, but that doesn't make them more accessible. So we're talking about people with, for example, low vision or who are blind users. So I have actually a long-standing collaboration here with a colleague at Michigan who developed a prosthesis for the eye, and we wanted to actually help people who lost part of their vision restore their vision, create rehabilitation that's enhanced through AR, VR. But I'll give you two examples of two things that I'm currently really thinking about. So one is, I think virtual reality, so the thing where you put on the helmet and you don't see the world anymore and you see this virtual world, is exactly that. It's primarily visual. In my courses, I encourage my students to think about audio. We don't have the access to haptic technology. We can do basic vibrations, but it's actually really hard to design not just purely visual, and we can do a little bit of audio, but we can't do a truly multimodal experience. So I encourage my students to think about that, but we are also constrained by what we can do in classes. One of the projects I'm working on is, for example, adaptive audio descriptions. So you are a blind person, you put on a VR headset, and yes, a blind person should put on a VR headset, and they should be able to see, maybe read out to them or through some other means by making the visual world, the virtual world, accessible to them through audio or haptic cues, be able to access this content. thinking about augmented reality, it's much easier. Like these glasses that I put on, they look a little bit like this, but they have a little larger frame and they have 2 cameras. And so the current problem is connectivity, and Jiasi is going to fix that for us. And also the way they are designed from an interaction perspective, it's really a prompt-based, like, hey Meta, what do you see? And then it's going to tell you, I see a very happy audience. They all are not hungry anymore. They also have been listening to us for a while. So Michael, you should really wrap up this panel. And these are things that these devices can actually tell you these days now. And I have a colleague in the School of Information who is actually blind, who recently joined us. And I'm learning a lot through him, who's experimenting with these technologies. And so I think the accessibility part on the AR headsets seems like a low-hanging fruit. It seems like, yeah, this is, but it's really, really hard to design it and to design user studies around it. So I do think this topic will stay with me for a while, and we can always do more. My own courses, for example, are not accessible. It annoys me so much, but it's so hard to make it accessible. It starts with motion sickness. If you have ever experienced motion sickness, I cannot force my students to try out VR. Motion sickness is, of course, a challenge. So thank you all for listening. Thank you all for being here. And we'll give it back to Jeremy.
Thank you so much. Great talk.